Hello everyone, my name is Kulli Ranjit Kumar. Today I will be presenting a seminar on switching theory and logic design, focusing on the topic of registers and their classification and the overview. Let's start with a basic concept. Here, what is a register? A register is a group of two or more flip-flops used to store multiple bits of binary data. Each flip-flop stores one bit, either 0 or 1. Here is the basic definition of a register. It is a register is a fundamental component defined as a group of two or more flip-flops used to store multiple bits of binary data. Registers provide temporary data storage and help transfer data between different parts of a digital circuit. All register operations are synchronized by clock signals, ensuring the data is stored or moved at precise intervals. This simple visualization shows an n-bit register where each flip-flop FF stores one bit controlled by a common clock. Classification overview. Registers are mainly classified into four types. They are serial in, serial out, SISO, serial in, parallel out, SIPO, parallel in, serial out, PISO, parallel in, parallel out, PIPO. In serial in, serial out, SISO, the input we have to take serial and it will come output as a serial only. The data enters and exits one bit at a time sequentially, used as time delay elements in digital circuits. And in serial in parallel outflow, input serial and output is parallel. Data enters serially but is available simultaneously at multiple output lines, used in serial to parallel conversion. Parallel in serial out. Here the input we have to give parallel but the output will become as serial. The data enters simultaneously on multiple input lines but exits one bit at a time, used in parallel to serial conversion. The parallel in parallel out, the input we have to give parallel, then the output will become as parallel only. The data enters and exits simultaneously on multiple lines simultaneously, used as temporary storage buffers for rapid data access. These differ in whether data enters and exits bit by bit or all at once. Each type serves a different purpose depending on the application. The registers depending on applications. First one, shift register and storage register. Based on these two registers, it will dependent. The CISO register allows data to enter and exit one bit at a time sequentially. Its operation is clock driven. Each clock pulse shifts data one position to forward. For a n-bit register, it takes n clock pulses to load all bits. These are mainly used as time delay elements in digital circuits. Now I will explain the working of a 4-bit serial in serial out shift register, which is shown in the circuit diagram. The circuit consists of 4 D flip-flops labeled as FF1, FF2, FF3 and FF4. Each flip-flop can store one bit of data, either 0 or 1. All 4 flip-flops are connected in series and are synchronized by a common clock signal. There is a clear input used to reset all flip-flops to 0 before starting a new operation. Now we will see the working principle of this circuit. The input data is applied at the serial data in terminal. When a clock pulse is applied, the flip-flop FF1 receives the first bit of data from the serial output. input. On the next clock pulse, this bit is shifted to flip-flop 2 and flip-flop 1 receives the next new bit. Similarly, on each clock pulse, the data shifts one position to the right from FF1 to FF4. After flow 4 clock pulses, hold one bit each, forming a 4-bit binary number. The circuit is a 4-bit CISO shift register. It consists of 4D flip-flops connected in cascade. Data enters serially and shifts right with each clock pulse. It outputs data serially as well, one bit at a time. Now we will see the serial in and parallel out. In a serial in parallel out register, data enters serially, one bit at a time, but all bits are made available in parallel at the output. With each clock pulse, data moves through the chain of flip-flops. After n clock pulses, the full data would appears at the outputs. These are common applications include serial to parallel data conversions and communication interfaces. Here is the definition of serial in and parallel out register. A register that accepts data bit by bit serially and outputs are bits simultaneously in parallel. The operation is the data enters serially one bit at a time. With each clock pulse, data propagates through the chain. After young clock pulses, an n-bit word is loaded. The applications is series to parallel data conversions and communication interfaces. Now I will explain the working of a 4-bit serial in parallel out shift register as shown in the circuit diagram. Here the circuit consists of 4 D flip-flops labeled as FF1 and FF2, FF3 and FF4. Each flip-flop can store one bit of data, either 0 or 1. All flip-flops share a common clock CLK line, ensuring synchronization. There's also a clear CLR input used to reset all outputs to 0 before loading new data. The working principle of this circuit is in the circuit, data is applied serially at the input DIN of the first flip-flop FF1. With each clock pulse, the bit at DIN enters FF1. The output of FF1 QA becomes the input to FF2. The output of FF2 feeds FF3 and FF3 feeds FF4. Thus, data bits moves on one stage to the right on each clock pulse. Therefore, this configuration is called serial in parallel out or SIPO shift register. This 4-bit SIPO register is a simplified yet powerful digital circuit that demonstrates how serial data can be efficiently converted to parallel from for use in digital system. Now we will see the parallel in serial out PISO. The PISO register does the opposite. It accepts data in parallel all at once and then shifts it out serially, one bit at a time. It was operates in two states. Load state when data is loaded simultaneously. Shift state when data is shifted out bit by bit. These are used in parallel to series conversion and especially to reduce transmission lines in communication systems. Here is the basic definition of piezo register, a register that accepts data in parallel and outputs it serially, controlled by a shift or load line. This is the operation and applications of this piezo register. Now I will explain the working of a 4-bit parallel in serial out shift register as shown in the circuit diagram. The circuit consists of four D flip-flops labeled FF1, FF2, FF3, and FF4. Each flip-flop can store one bit of binary word. Each flip-flop is controlled by a common clock CLK signal, ensuring that all flip-flops operate in synchronization. There are also parallel input lines and or logic gates are used to control whether data is loaded in parallel or shifted serially. The working principle of this circuit is the piezo resistor works in two modes, load mode and shift mode. First we will see the when the control signal, usually a load or shift load line, is active for loading, each flip-flop receives its bit directly from the parallel input. This operation happens with one clock pulse, meaning the entire 4-bit word is stored at once, and the second mode, shift mode, serial output. After loading, the control lines switches to the shift mode. Now, with each clock pulse, the data in the flip-flops begins to shift one position to the right. The output of each flip-flop becomes the input for the next one. Uh, Here, uh, the parallel in serial out shift register is a key digital component that efficiently converts parallel data into serial form for easy transmission and storage. Now let me explain the parallel in parallel out register PIPO. The PIPO register is designed for the fastest data storage and retrieval. Both input and output operations happen simultaneously in parallel. All four bits are of data are loaded with one clock pulse and are available immediately at the output. These registers are used as temporary storage buffers within processors and data holding elements between stages of digital systems. Here is the basic definition of PIPO register. The parallel in parallel register is designed for rapid data storage and a retrieval with simultaneous parallel input and output operations. And here is the operation and the applications of this PIPO register. Now I will explain the working of a 4-bit parallel in parallel out register as shown in the circuit diagram. The circuit consists of 4 D flip-flops labeled FF1, FF2, FF3 and FF4. Each flip-flop stores one bit of binary data, either 0 or 1. All the flip-flops are connected to a common clock CLK line so that they all operate simultaneously. Each flip-flop has a parallel input DA-DB, DC-DD, and a corresponding parallel output QA-QB, QC-QD. The working principle of the circuit is the PIPO registers allows data to be loaded in parallel and read out in parallel. When a clock pulse is applied, all four flip-flops store their respective input bits at the same time. The data on the input lines DA, DB, DC, DD are transferred to the outputs QA, QB, QC, QD in a single clock cycle. This means the entire 4-bit code is stored and made available immediately. Since both the input and output operations occur simultaneously in parallel, this configuration is called parallel in parallel out or PIPO register. Registers are essential components of digital circuits. They store data temporarily and transfer it efficiently between system parts. Depending on input-output configuration, they can act as shift registers or storage registers. The four main types CISO, PIPO, PISO, PIPO, and each have distinct applications in data handling and conversion. That concludes my presentation on registers in switching theory and logic design. Thank you for your attention.